My name is Mojca Baudaš. I come from the University of Ljubljana in Slovenia, where this session is hosted today, and I'll also act as a facilitator. Let me first explain for any newcomers that EMOS stands for European Master in Official Statistics. It's a joint project of universities and data producers in the EU member states, EFTA, and EU candidate countries. Now, the network, the EMOS network, now comprises 23 master programs in 15 countries, but it's expected to grow soon as the third call for application has been launched. Now, let me explain how we run the webinar today. As a participant, you can watch and listen to the session. And to interact with the presenter, you can use the chat window on the right, where most of you already said hi. We encourage you to post questions here in the chat window throughout the webinar, and the presenter will respond during several question breaks. Now, should you have any technical question, we just advise that you try restarting the Adobe Connect or the computer, and this usually solves most of the problems. And now to the topic of today's webinar, statistical editing. An important phase, so the editing is an important phase in official statistics production because it consumes lots of resources and is at the same time essential for data quality. I'm very happy to host today a colleague from Statistical Office of the Republic of Slovenia, Rudi Seljak. Rudi, hi.
Hi.
Rudi is a general methodologist. He started his work in official statistics as a sampling expert. He devoted then part of his career to quality assessment, and in the last few years he's been mostly working in the area of statistical data editing, and he's also been trying to set up more efficient statistical processing. Rudi, please, the floor is yours.
Thank you, Mojca, and warm welcome from my side too. Before we go to the real business, perhaps just a few introductory words. As it was said in the title of this webinar, this is introduction to the statistical editing. So this is in fact a kind of introductory level. So we all know that it's the data editing is very, very wide area, and we can in 1 hour we can in fact only cover just a little part of this. So I will just try to make a quick general overview of this complex area, and I will try mostly to focus on the practical issues that are connected with statistical data editing. Perhaps I will not go so deep into some theoretical discussions. I will just mention them, but the goal is to make more practical presentation. So just a quick summary of the content. At the beginning, we'll just look at the data editing and the whole statistical process, where we can place data editing in the statistical process. Then I will introduce some basic concepts and definitions. And then we will go to the main question of this presentation, how to make the data editing process more modern, more efficient, and I will try to make some guidelines for direction which should go someone who is trying to make the statistical data editing process more efficient. At the end, I will just, in fact, briefly tackle also one very vital area, this is imputation methods. Because the imputation methods are so much connected to the data editing, I included it at least one short part of this area. Okay, so perhaps just to mention that it's quite non-technical presentation. If any one of you read the famous book from the famous scientist Stephen Hawking, The Short History of Time, in the foreword to this book, he claimed that each formula at least halved the number of readers. But anyway, he put one formula in his book. I was more strict in this. I didn't put any formulas. So I hope that most of you will stay till the end. Okay? So let us begin with the basic question. What in fact is data editing? We know that the data is the basic material for all statisticians. So for us that are working in official statistics, the data is a basic material for our production. And we all know that almost each data set that we are working on is somehow infected with errors. So errors occurs in different stages of survey implementation. We can say that in general, I could make three groups of where errors occur. The first group is the stage where the selection of observational unit is done. So this is mostly referring to the sampling errors or coverage errors. So in the first phase, the first group of errors occur. The second, very wide types of errors, let's say, occurs in the data collection process. And the third stage, where also quite a lot of errors occur, is the data processing. So if we are looking at these three groups, wide groups of where errors can occur, I can say that in our presentation we will mostly focus on the errors that occur during the data collection, and perhaps also some of them during the data processing. We will not tackle the problem of sampling errors or coverage errors, because this is tackled with other presentations and other webinars. So what is in fact data editing? In fact, the definition is quite simple. The term data editing denotes all activities aiming at detecting and correcting errors in the data. So we want to find errors and we want to get rid of them. As usually in such cases, the simple definition is then consequently make the process that is based on this definition quite complex. And it's the same with the data editing. In fact, the data editing is much more complex than it seems on the first sight. And we will try to make some indication why this is so during this presentation. Also, the fact is that data editing is a very important part of the statistical process. Perhaps two main reasons for that I see, that I can tell at this moment, is first that the data editing is very time and resource consuming. Now, some older researchers indicate that the percentage of budget that is usually devoted to data editing is 40 to 60%. Some recent studies lower this figure to 30 to 40%. Now, of course, it's very different on which survey we are talking about. This big, large numbers holds mostly for surveys that use self-completion data, like self-completion paper questionnaires. Let's say it's quite different in, let's say, face-to-face data collection mode, because there the costs of the data collection is so high, so percentage of data editing is definitely lower. But if you are talking about self-completion questionnaires, certainly I think the 30 to 50%, let's say, is very frequently the share of budget that is devoted to data editing. The second issue that makes the data editing so much important is that it has a very large impact on the quality of statistical results. So in fact, I think that very frequently the data editing as a issue for data quality is underestimated. I mean, there is a lot of theoretical textbooks about sample selection, data collection, and the errors that should be avoided there. But there is not so much theoretical work on data editing so far. This is still more on the practical level. So there is still a lot of space to make some more firm, more wide theoretical frameworks in the data editing area. Perhaps just to mention, because we should refer mostly to the official statistics. Why is data editing especially important in the field of official statistics? I also see at least two reasons for that. On one hand, we all know that the requirements for the accuracy and reliability in the official statistics is very strict. We make official figures, so our responsibility is that the data are as accurate as possible. This is the one issue, and the other one goes in the other direction, that perhaps the fact is that sometimes data editing is easier to do in official statistics, and the reason for that is that we have usually a lot of auxiliary data on the disposal. So we have administrative data, we have data from other surveys, and it makes sometimes, if we can use this auxiliary information, we can make the data editing more efficient. Okay. Now we try to place the data editing process into GSBP model. But before this, I would just put the first question to you. And this is very simply, are you familiar with GSBP model or not? Please use the poll that you get, and I'll give you 30 seconds. Okay, I think we can close the voting. Okay. I think you can see the result. It's almost half-half, so that's interesting. So half of the persons already heard about it and half not. I'm quite sure that if 5 years ago I would ask this question, that the relation would be quite different. But I think that now GSBP model is quite familiar, and I'm glad to see that a lot of people already know about it. So before we start to place data editing in this model, just a few words about GSBPM model. This is a model that is a result of a joint work of 3 institutions, UNICE, Eurostat, and OECD. I think the first version of the model was released in 2009, and I think an upgrade was made somewhere in 2014. There is 3 levels of this model. The first level is statistical process as a whole. Then it's divided into now 8 phases. The first version had 9 phases, and each of these phases then is divided further into sub-processes, different number of sub-processes. What is idea behind the GSBPM model? The basic idea is to generate a generic tool to describe the statistical survey process in general terms. Because, you know, if you are talking to the people that are dealing or that are managing this survey, they will always say, oh, my survey is so much different than other surveys. But if you look at the activities that are carried out inside these surveys, you will see that they have a lot of common elements. And this is exactly where the GSBP model is built on, trying to define the common parts of the implementation of the statistical survey. Now, of course, this is a general model, and it cannot fit in every situation. And that is also the reason why several countries already made an adjustment of this model and made their own model. For instance, even also Statistical Office of Republic of Slovenia made, on the basis of this model, its own model. And if you go to our website, you will see our adjusted model. I can just say that the first level remained almost the same. I mean, the phases, while we quite significantly changed the list of sub-processes. Okay, but now the key question here, where is data editing in this model? Well, the first, I think, three sub-processes that can we immediately detect are the ones that already have something connected to the data editing in its name. This is review and validate in process phase, edit and impute in process, and validate outputs. This is let's say, explicitly referring to the data editing. But if you look at the data editing a bit broader, you will see that it comes also in other sub-processes, because the fact is that data editing can be included also in the earlier phases of the process. The typical example, I think most of you know, is the other questionnaire which are built in a computer-assisted way. So if you have computer-assisted way or web survey, which is very similar when the questionnaire functionality is in question, is that you can already include some validation controls inside the questionnaire. And if you have such case, it's certain that the data editing already occurs in the earlier stage of the survey implementation. So, but if it's already in the collection phase, we can go also to the left and we say, okay, but here we have design. We have to make the validation rule. We have to think about validation rule. We have to program them. So in fact, if we look a little bit wider, we can see that editing is here also in other sub-processes. I make a circle here in the processes that I think that at least partly explicitly or implicitly is involved, data editing here is involved. I think that somebody else could find another sub-process. But what I wanted to show you is that data editing is not just processing, it's not just analyze it, but it's coming into the statistical process in several phases, in several sub-processes. But we will talk about this later a bit more in detail. Okay. Oh, okay, I forgot perhaps this one, which is also very important. In fact, the evaluation phase. The evaluation phase is so much important because only on the evaluation basis you can make improvements. So also the editing process should be constantly evaluated, and on the basis of this evaluation, the action improvements should be made. So I denoted all these three sub-processes that are in the evaluation phase that are also connected to the data editing, or that data editing is also can be placed here in these three sub-processes. Okay. Perhaps just one graphical presentation. I will make a very simplified presentation of how the survey implementation looks like. This is perhaps too simplified, but it's illustrative. We usually begins with a set of the observational units. We will not deal, is it a random sample, is it a census, is it a cutoff sample? We have a set of observational units. When we go to the field and start collecting data, usually this set of observational units divides into three parts. The one part is we find out that some of the units are not eligible anymore, let's say the company that not operate anymore, or the person who had moved to another country. So one, let's say we hope smaller part of our set of observational units turns out that it's ineligible at the time of interviewing or collection of data more general. Then we have almost always also the part of the units that don't want to respond, or we are not able to contact them for different reasons. We denote this set of subgroup of observational units with non-response. And then we have the last group, for which we hope usually that is the largest one, the group from which we get response. Is it complete or incomplete? We don't care about this now, but these are the units from which we have got at least partial response. And this is the fact, these responses and their data is the set of units that we are working on when we are talking about data editing. So when we do the data collection on these units, we end with the input data. And this input data, let's say we can imagine that this is input into our production process. And first thing when we do this, when we start to to make the data editing process is we try to validate this data, try to find out how these data are. So we here place the validation process. And when we make the validation process, we usually find out that part of this data are missing and part of this data are inconsistent or at least suspicious. And the aim of data editing process is exactly this situation that is here. We are targeting this situation. We want to get rid as much as possible of this missing data and inconsistent data. Well, I will not say all of them. We will talk about this later, but we want to get rid of most of them. Just a short remark. I am now referring only to the situation which is called usually the post-collection editing. We will not deal in this presentation about the editing that is included in the data collection, the one that I already referred before. So the data editing that is included in, let's say, web questionnaires. So we are mostly will talk about post-collection editing. When we have data, we want to validate them, and then we want to get rid of most of these, let's say, strange things in the data. Okay, this is the situation that we are facing. We start with data editing. Okay, the typology of errors, it can be done in several ways. I will just make one division of errors, which is from the data editing point of view perhaps the most important, and that is a division to the systematic and random errors. In very simple terms, I would say that systematic error is the error where the errors are distributed, I would say, not uniformly around the right value. In more technical term, I would say that the expected value of this error term is not zero. In the contrast with the random error, you can see this presentation here, where the errors are distributed, let's say, more uniformly around the right value. So technically speaking, here we have the expected value of the errors is in fact zero. So here you already see the two examples, perhaps most frequently, the two examples that you most frequently meet when you're when we are talking about systematic error. One is measurement unit error and one is misunderstanding error. Measurement unit error simply means that the respondent used a wrong unit for reporting, let's say euros instead of 1,000 euros. In this case, all his figures are 1,000 times too large. And this is certainly, of course, the systematic error. The misunderstanding error is in fact the consequence of the, let's say, bad formulation of the question in the questionnaire. So most of the respondents misunderstood one question, and that's why we got the wrong answers in the same direction. What are the examples of random errors? Two typical examples are typing errors. Typing errors, of course, is a random error, because you sometimes make typing errors that results in larger and sometimes in smaller values, and rounding errors, which is the same case. Okay. What can we do to distinguish this one? In fact, perhaps just this one, this issue before we talk about how can we detect one error and how can we detect another. What is the consequent effects of systematic error and what is the consequence of random error? At the first sight, we always say the systematic error is more problematic because the consequence of the systematic error is in fact bias. it is the direct consequence of this definition of systematic error. If the errors are systematic in one direction, also the result will be biased in one of these directions. There's a lot of units report measurement unit error. You will of course get too large results. In this case, when you have euros instead of 1,000 euros. In contrary, in random error in fact don't generate bias, but they just increase the variance of in your data. Where someone would say that this is not so much problematic, but I would still say that also random errors are problematic, and they are problematic from this point of view because they are much more difficult to discover. Systematic error, especially like measurement errors, it's usually not so difficult to detect them because they outstand. But random errors many times stay in the data and they increase the variance of your results, and you don't know that. Okay. Okay, now let's go to the methods for data editing. There are several groups. I will just make one grouping of methods for data editing, and this is division between microediting and macroediting. Microediting means that you are looking at each record individually and try to find inconsistencies and errors in each individual record. And then, of course, that you correct this if needed, you correct these errors. Macroediting means that you don't look just at one individual record, but more units or even aggregates at the same time. So macro aggregates can be divided roughly in two groups. One is validation of aggregates. So it means the aggregated data, your statistical results are analyzed and verified. This is in fact the procedure that each statistician does before he publishes the results. He looks at, let's say, results from the previous publication or results from the similar survey and try to find some strange figures in his aggregates. We call it validation of aggregates. The other type of macroediting is analysis of distributions. So you usually plot your distribution of your data, of the whole set of the data, and try to detect some strange patterns in your data. Usually this analysis of distributions is used to detect outliers, because outliers are very easy to detect through the visualization methods. And analysis of distribution is mostly about visualization. But we will talk about this a bit later. Okay. Usually the macro editing is placed at the end of the statistical process. So the classical flow goes like, first you do micro editing, then after this you make macro editing, and if needed you go back to the micro editing, because we have to stress out one very important thing. The macro editing is in fact should be done only to detect suspicious data. And then it should be followed again by the procedures on micro level. The correction should never be made on the aggregated level. You should not correct the aggregates, but you should go back to the micro level and find the reason on the micro level why some aggregates are a bit suspicious. Okay. One very important issue in the data editing procedures is the relation between manual and automated editing. Detection of errors, as we said, let's say, perhaps we say again, the whole data editing process consists of two large phases. The one is detection of errors and the other one is correction of errors. The fact is that detection of errors, so data validation, is to a great extent already automated. It's done with the computer because it's very easy to do data validation with the computers. But the correction of errors here, I have to say that still to a great extent is done manually. I mean, manually here, you have to understand it's not like literally manually without computer. Manually, we here think that it's not done with a systematic computer procedure, but you look your data, you verified it through the telephone contact it's needed. Sometimes you just by your expert knowledge and you correct it in the micro level. We'll call this manual editing. So no computer procedure that can make some corrections on the whole data set. So the fact is, at least from my experience, that a lot of data correction, especially in the case of business survey, is still done with manual corrections. This manual editing, just to mention, sometimes you will also see the term interactive editing. So each suspicious unit is treated individually, verified and eventually corrected, and as already said, verified by recontacting reporting unit, by using other administrative sources, let's say, or by using your expert knowledge. So using your expert estimates. But anyway, the characteristics of this manual editing is that you are doing this on the individual level for each unit. The fact is that what makes data editing so much very time consuming and costly is this manual editing. So here we have a lot of spaces for improvements and to make this editing more efficient. But before we go to this, again, to this data editing, to this automated and relation automated and manual data editing, just a quick look at data validation. I already said data validation is used to find errors. There are validation rules usually that are written in the computer language that are used to discover errors in your data. These procedures are usually done with a special software, and they just detect erroneous or suspicious values. I will tell you this distinction between the terms later. And this data validation is based usually on the set of validation rules. You have a lot of these rules that help to find errors in your data. Just perhaps one small remark. Validation rules is just one term that is used here. Sometimes you will hear the edits rules or checks, but I will use validation rules through this presentation. I have to point out again that set of validation rule is a cornerstone of the data editing process. Everything starts with the validation rules. So it's worth investing some time to make a good validation rule, to good set of validation rules. What is good set of validation rules, I will tell you a bit later. Perhaps just one division in this validation rule. We usually distinguish between hard rules and soft rules. Then hard rules are the rules that will detect data that are certainly erroneous or that are erroneous with high probability. Let's say one example of this is the turnover should be larger or equal to the profit. Another example of such validation rule is, let's say this. The rule is that age of the person, let's say that we have the survey of persons, that age is 16 and status is student. This denotes the error. Well, is this a hard or soft rule? I mean, it could be sometimes this situation that this data is correct, but it's very improbable, at least in Slovenia. In Slovenia, usually student starts at 19 or at least mostly at 18, but very, very rarely that you find someone that will be 16 and will be student. So this is not with 100%, but with high probability this will detect error in your data. But I will still put it in the hard rules. When the soft rules usually just detect the suspicious values that can be errors or perhaps they are not errors. Let's say one typical validation rule that is in fact soft rule is when you're comparing your data in, let's say, in short-term service, data from this month and data from previous months, and you say, okay, if number of employees this month is larger than 50% from number of employees from previous month, this is probably a bit suspicious. But it's not necessary that it's an error. It's of course because something happened to the enterprise. Okay, so we have hard rules and soft rules in the data validation rules. Now I will just make one grouping of these validation rules. Of course, these groupings, we can make different groupings. I just choose one for this, make distinction between different rules. The first group of rules that I see is the integrity checks. This is the rules that you are using when you are putting your data in your database. So this is the basic constraint rules, like let's say non-existence of the unique identifier or duplicates that you usually get, because usually your database is constructed in such a way that you cannot insert duplicates inside, and you have to deal with these problems before you insert this into the database. The next group of validation rules, I will call them plausibility check. These rules, in fact, look just one variables at a time and check if the value is in the prescribed range. Let's say typical example is the gender can be only male and female, and let's say, and the turnover must be at least 0. It cannot be negative. These are, let's say, typical example of plausibility checks. The next group, which is perhaps the most common validation rules, are the consistency checks. We are here now checking relations among several variables. Not just one variable, like in plausibility checks, but several variables. Let's say here one example from the, let's say, survey of persons. If you have a data that one person have a status employed, then his age should be, by our law, at least 15. And if you have the data that are not connected with this relation, you have almost certainly an error. Okay, and another very typical example of validation rule is also this one, that if you are looking at the export of your enterprises, and in the export into the euro area plus export in a non-euro area should be export total. This kind of the checks or validation rules that are in fact equalities are also called balance checks. And the last group, I would name them checks in distribution. Here we are not dealing anymore with just one record, but we are examining distribution of the variables. This is similar as I was talking before in macroediting. So we are investigating the distribution of all the units, and this already, I said, is mostly used to detect the outliers in the data. Okay. Perhaps some quick words about outliers. Outliers sometimes also refers to as extreme values. One definition of outlier I wrote is value that significantly deviate in the data distribution. The problem here is, of course, this word significantly. That makes the outlier, in fact, the relative term. It's never the absolute term. It's always depend on some parameters that you put in the process of your procedure of detection of outliers. In a way, you choose what will be outlier for your data and what will not be. What is important to distinguish here with outliers is perhaps here this, that outlier is in fact the value that it's somewhere in the distribution that deviates from others, but it can still be correct. This is the first option, of course. And even if it's correct, it's still two options that you have here. One is that this outlier is a representative outlier. So this means that if you have a sample, that it can represent so many outliers like your sample weight is. Or the other option is that it's non-representative outlier. So it's one of a kind, let's say. If you get in your sample, let's say in Slovenia, that we will got a famous basketball player, Goran Dragic, we know that his salary is very high. He's not representative for a large group of other persons in Slovenia. Okay. The other option is, of course, that the outlier is the consequence of this, that we have incorrect value, that we have error in the data. And of course, what to do with these types of outliers? If it's incorrect value, the right thing is to correct it. If it's representative outlier, the right thing is to leave it as it is. If it's non-representative outlier, the solution is that you put his weight to 1, or at least that you trim his weights. But the problem here, of course, I will not tackle this because it's another wide area, is how to detect in your real data which outlier is representative, which is error, which is not error, etc. And this is in fact a very large challenge when you're dealing with the real data. Perhaps just to mention that some statistics are more sensitive on outlying values like means, as others like medians that are more robust. One way to detect outliers are graphical methods. I already mentioned this. And the other is to do it with automatic detection. This is in fact that you use formulas. If you use formulas, you can use formulas for univariate detection. So you are just looking at one variable at a time, or you can make it for the multivariate distribution. Here in the univariate detection, I said I will not write the formula, so I didn't write the formula. I just perhaps to mention that most of these formula are based on the distance from the median. Like multivariate distribution is a very similar story. It's several methods, but most of them are based on multivariate distance, like Mahalanobis distance, from let's say, from central point of your data. Okay, here I will just show 4 types of charts that I frequently used to detect outliers. One is histogram. You know histograms, I believe this one, and you can see one example where the outliers are quite clearly seen here on the right. The next one is box plot. The box plot is also used to make to present the distribution, but here are denoted also some parameters of this distribution like median and quintiles, and also the outliers are already marked here especially. So box plot is very useful to detect outliers. For periodic surveys, when you are measuring one phenomenon for several times, like monthly survey, it's very useful to make a line chart, and sometimes you can see the variates here in this line chart, some strange patterns in the line chart. And the last one is the scatter plot. The scatter plot is designed to present you the relations with 2 variables. We don't have time to go deep into this, how to detect variables, but just on the first slide, now will be the question for you. What do you think, which of these 4 graphs is most useful as a presentation tool or to detect outliers? Okay, can we?
Any more?
Oh, still changing.
Coming.
Still changing.
Yeah, still changing.
Okay, we'll wait a bit.
Just cast your votes.
Okay, should we stop?
Yeah.
Okay, you can see the votes. It's quite interesting. The scatter plot is the leader. I didn't expect such results. I would be more for histogram and box plot, but okay. The fact is that you have several data and more connected variables. That's true. The scatter plot is very useful, and others are quite equally distributed. Interesting. Okay. Okay, we should go further. One very important concept, especially when the automatic editing is in question, is the term of acceptance region. Acceptance region is in fact the set of acceptable values determined by the set of validation rules. In fact, all your validation rules, if you put them together, determine the acceptance region for all your variables that are validated in your system. In fact, each validation rule determines one subregion, and when you put this subregion together, you can get the acceptance region as a whole. Of course, rules with one variable, in these rules, it's the easiest way to determine the subregion because it's determined absolutely. I will show you an example later. When you have several variables, you can only relatively determine your subregion. Perhaps it's the easiest way to show you this, to explain you through example. Let's say you have here this very simplified example of 3 units and 3 variables. You see the values of these variables here. And then you have this, let's say, four validation rules. And it said z should be larger than 5 and less than 10. X should be larger than 0. Y should be larger than 0, and X should be larger than Y. Well, of course, you can see that the Z is in a way isolated here. The rule is also directly on Z and not connected with other variables. And for Z, it's quite easy to find the acceptance rule. It's simply between 5 and 10. What is in this interval is okay. What is out of this interval is out of the acceptance region. The situation is a bit more complicated for X and Y because they are connected with the last validation rule, which is said X should be larger than Y. And if we try to find acceptance region for each of these units, we can say, okay, Z is independent on the unit. The 5-10 interval is acceptance region for all units. When X and Y are in question, each of these units you see have different interval because it's dependent on the value of the Y. And you can see I plotted here to you the acceptance interval for each of these units if you look in X dependent on epsilon and Y vice versa, Y and Y vice versa here. So it's very useful if you draw this, if you try to draw the acceptance regions into the graph, because we are talking now about just about X and Y. Z is quite simple, it's straightforward. But let's see X and Y. X and Y, because just at 2 variables, you can plot it in 2-dimensional space. And what is the acceptance regions here? Acceptance regions here is in fact this area under this line here. It's mathematically quite simple to determine this, you see. And if we plot these 3 units into this picture, you can see that the first one is outside the acceptance region, so it's probably we can say that it's a suspicious unit. The second one is okay because falls inside the region, and the third one, this is in fact at the border, but because if we go back and see that X should be strictly larger than Y, then it's still a suspicious value here. But it's a nice graphical presentation that you can understand what acceptance region in fact means. Okay. Just a quick categorization of data validity. In fact, when we are thinking about validation of the data, it's not so simple that it looks at the first sight. There is, of course, several categorization, but again, I made one, which I think it's quite useful. I said the first division of data, I would say, let's divide it to the correct, incorrect. Correct, I would say the data would be confirmed as correct as plausible if could be checked with any disposable means. I will here not operate with the term true value because it's sometimes difficult to say if the true value exists or not. I prefer correct value. Correct value is the one it's confirmed of correct if it's correct, if it confirmed, if it would be confirmed if you would use any means that you would have on the disposal, and then you would correct said it is correct or incorrect. The other division is acceptable and suspicious value. These are connected to the data validation rules. So we will say that one value is acceptable if it passes all the validation rules, if it goes through all the controls, if not, it's suspicious. And then we can, basis on this division, we can make this division of units. If you're, let's say, have n units, then you can divide it into 4 categories. When you're done with your validation rules, you can have units that are correct, but your system make them acceptable, correct, suspicious, incorrect, acceptable, incorrect, suspicious. Well, what would we look for here? We would look here that N1 and N4 are as large as possible, and N2 and N3 as small as possible, because we would like that correct units are confirmed as acceptable and incorrect are denoted as suspicious. But of course, in the reality, is not always like this. I would just ask you one question. What do you think in a business server? What is the most, which of this category is usually predominant?
Okay, let's wait for some more votes. Though the time is running out, so. Okay.
Okay.
Maybe a few more moments. You can maybe broadcast through the results and leave the thing open for a while.
Okay, so the majority thinks that N1 is predominant. Yeah, this would be good that this one would be predominant. But from my experience, in fact, N2 is very frequently predominant. It means the units that were denoted as suspicious but turned out that are in fact correct. Why is this? I will talk about it a bit later. Thanks. This is usually because of the phenomenon that is known as overediting. What is overediting? Overediting, we come to the overediting in the situation where we have too many validation rules with too strict conditions. The data producer, when they validate their data, they want to check them too much, let's say, within this, and they set too many rules, too strict limits. What is the result of this is that we have too much verification to do, and very frequently this verification is done with manual editing. And the negative consequences is, of course, that resources are not in proportion with the improvements of the quality. We have to verify a lot of data, but we don't correct a lot of them. And another negative consequence is that too many rules have to be verified. The significant errors can be left in the data. So sometimes to really important errors. So what can be done to go over this problem of over-editing? One thing is, of course, that we careful planning and testing of controls, of validation rules, so that we really try to make more efficient validation rules. And the other one is that we restrict individual verification, the manual editing, also to the influential errors. And if we want to do this, we come to the selective editing approach. What is selective editing approach? Selective editing is, in fact, that we try to make a procedure that among all the errors that occurs in our validation procedure, that we also only detect first the significant errors, the errors that really impact our results. Usually it's quite complicated mathematically, but usually it's based, this selection is based on the difference between reported and expected value. Expected value is the value that you would, let's say, estimate if you wouldn't have the error, the data. And if the data that really comes to you is very much different than the one that you expect, usually it's a signal that it could be an error. Mathematically, it's done through the so-called score function. Score function means that all your units and all your errors in your units, you make a scores on them, and only the units and data that gets the highest score are then verified manually. Usually you have one local score for the particular variable, and then you calculate the global score for the whole unit. So the fact is that the selective editing can significantly improve efficiency if you do it in the right way. This is, let's say, one example of the implementation of the selective editing. So if you have raw data with errors at the beginning, first you make data validation, and then you make score function that make this division. Some units go to the manual editing, and some units go to the automatic editing. This means that just part of the unit will be verified manually and corrected if needed, but part of the unit will be corrected with automatic procedures. And then it's followed by macro editing. If it needed, we go back and go to through this procedure again. Perhaps we will just go quick through this one. I would just want to mention that there are two basic implementation of automatic editing. One is fully automatic editing, where the procedure is based only on the data and validation rules. So you throw, let's say, your data and your validation rule in one procedure, and this procedure makes corrections, automatic corrections for you. Of course, it has to be pointed out that these corrected data are not correct in the sense that we defined before. These are in fact just acceptable data. They go through the validation rules. So you don't have any guarantee that there are no errors in this data anymore. The other way is that you okay, here have the first supplement to the automatic editing. The fully automatic editing is usually done on the basis of the Seljak approach. Just very simply to tell you the basic idea of Seljak approach. The basic idea is that usually when you have data, when you have one record and it's suspicious, you have to decide which of the variables should you correct when you make automatic corrections. And Seljak approach say correct the least possible number of units. Let's say this example, if you have here the unit is outside of acceptance region, you would want to put this into the acceptance region. Of course, the first idea would be, let's make this movement here at the shorter distance. No, but the Seljak say, no, if you would put it here, you would change X and Y. But the idea here is just to correct one. So the Seljak approach, correct just X, correct just Y. How is this decided? These are procedures. I will not go to this because they're quite technical, but the basic idea is this one. Change just one variable. The other implementation of automatic editing, we call it semi-automatic procedure, is that is still one step in between that is in fact human factor. Because you take your data, your raw data, you take your validation rules, see what errors are, and then you write your processing rules how this should be corrected. And then this program, you have to have the program that makes these corrections to you, and again you have acceptable data at the end. But the main reason, the main difference here is that here this step has processing rules that are done with you, by human intervention here. Okay. I think we are...
The question
Oh, sorry. Yeah. When we are talking about the automatic procedure, what do you think, which is the main shortcoming of this automatic editing approach, that the machine is correcting your data?
Yeah. And while we wait for the answers, we can quickly stop and restart.
Okay.
Maybe start broadcasting.
Okay. Yeah, I think the answer is quite expected. The most problematic, let's say, in a way, is that this automatic approach represents a black box syndrome. Most of the persons that are not familiar with this procedural Faraghi-Hot approach don't know what is going on in this black box in this program, and that's why it's so difficult sometimes to introduce this to the subject matter statistician, let's say. Well, okay. I think this is biased now because I already said.
Yeah.
Let's say in a way solution.
Rudi, before going on, I would pose you some questions that came in during your talk. Maybe we can start from the back. Could you give an example of a score function? So when we were talking about selective editing, you were mentioning the score function.
Yeah.
So could you give an example or explain how it looks like?
Yeah, it's difficult to give an example. I can just try to quickly sketch the score function. The score function is in fact mathematical procedure that gives a score to each unit at the end, and each unit shows you two things: how significant errors have this unit, and how much impact can these units have to your final results. And these two factors are in a way incorporated into these mathematical procedures that can be then used to rank your units from the most important to be reviewed and to the least one. It cannot be explained in 2 minutes. It's sometimes quite complicated how this function looks like. But the idea is this one: make a function that will give score to each of your units that is suspicious, and to put at the top the units that are more important to be reviewed manually.
Mm-hmm. Okay, and now also back to the question of outliers.
Okay.
Yeah. The question. Okay. Karsten has another question. Maybe you can read in the chat one, or I can read it out. Is the score function meant here the same as the score function defined for maximum likelihood estimators? For instance, the gradient of the likelihood or log likelihood function?
Oof, I have to say that I'm not quite familiar with this class, but I would say I think no. I think these are the different concepts, because the score function is quite specific just for selective editing.
Mm-hmm. Yeah. Okay. And if we go back to the outliers, so Daniel was asking, when you have an outlier, how to distinguish between a correct or an incorrect value? What is better, to edit the outlier or to delete from your data?
Oof, this is the question that is impossible to answer. As I already mentioned, this is one of the main challenges. Usually you have to rely on subject matter knowledge. They have to estimate if is it possible or is it not possible that the value is so high. Here the technology then will not help you very much. If you get in your let's say in your data the person, let's say, that was on the traveling and spent in Slovenia, let's say 3,000 euros in 1 month, or so sorry, in 1 week, is it possible? Yes, of course, I think it's possible. He can go to the casino and spend the money here or something. But the more important question here, is this a representative? How frequent this can happen? This can influence much more your results. It's not so much a problem that you leave your outliers in the data. The problem is if you leave the weight of this outlier. So I think it's more important to ask yourself, is it really representative or it's not? Or you can just isolate this data and put the weight to 1 for this data.
So it's important that the error does not get exaggerated.
Yeah, and it's not influence your results so much, you know. That's important. Not to introduce too much bias by this outlier.
Okay, and we have one more, let's say, comment more than a question. Careful with box plots because it depends on how the whiskers are defined.
Yeah.
Of course, the whiskers could be just the minimum and the maximum of the distribution. They can be a certain percentile, or then can be, as Taki defined them, like depending on the interquartile range. So, of course, this is just one way. It's not a determination. It's just one way to help you.
Yeah, I totally agree. But this is corrected with the definition of outliers, because the picture that the graph that I show you is in fact the box plot that has outliers already detected. And of course, it's question how these outliers were determined. And this is done on the arbitrary basis. Someone have to make parameters what is outlier, and that's the problem here. But of course, you can make box plots also without outliers, and then you don't have this problem then.
Okay, so maybe we can move on to the imputation methods. And then, of course, if you have more questions, please do write them in the chat. We'll dedicate some minutes at the end to the questions as well.
Unfortunately, we don't have a lot of time for imputation methods. So I will just list 4 of the methods. There is a lot of imputation methods that are used through the editing process. I just listed 4 which I think that are most commonly used in official statistics. The first one is the mean imputation. It's very simple way of imputation, very simple idea. If you don't have a data for a certain unit, estimated by the mean of these units that responded. Of course, it's very simple, but also has its problem. It's in a way it is problematic. The main problem here is that if we do this imputation, we in fact artificially decrease variability of our data, because we give the same value input to several units. And it is, in a way, it's sensitive to outliers, like mean. It's quite sensitive to outliers, and we can introduce bias with such imputation. The solution to this one, to outliers, is that we make trimmed mean, or that you make more robust moments like median, let's say. The second one, which is also quite frequently used, but perhaps more frequently in business surveys, is the ratio imputation. This is in the case if we have highly correlated auxiliary variable on disposal. Because I said I will not write you a formula, I will just try to explain you how this ratio imputation works. When you making the imputation, you first calculate average ratio of responded units. Let's say an example. You have turnover that you are collecting, a number of employees that you already have before the survey for all the units. And when you face the missing value, you first take all the units that responded, take their turnover, take their number of employees, and calculate the average turnover for one employee. And then you take the unit where you want to impute the turnover, take his number of employees, and multiply these two values, and then you have the estimation, your imputed value. Okay. Very quickly, we go to the next one. The next one is perhaps, at least in some areas, the most usually used method. This is hot deck imputation. Also, the idea behind this method is very, very simple. If I don't have a value for one unit, let's try to find a similar unit and take the unit from that, the value from that unit. The unit from which we taken the imputed value we usually call the donor. That's why this methods or group of methods is also set donor-based methods. And there are several implementations of this donor-based method. One, and more or less they all differ on how the donor is selected. One way how the donor is selected is that you randomly select them, and this is random HODEC. One way is that you order your units by one variable, and you take the donor which is the closest to the unit that you are imputing. Very similar to this one, but perhaps more sophisticated, is that you calculate distance between units on the basis of one matching variable, and then you choose the donor which is the closest one, which has the lower distance to the unit that you are imputing. The last group of methods that's also very frequently used in official statistics are the methods that are denoted as historical imputations. The idea is here is that if you don't have the value from this implementation of survey, take this from some previous implementation of the survey. Of course, this method can be used when you are dealing with periodic surveys. So let's say like monthly survey or quarterly survey. This is mostly designed for such short-term surveys. Of course, even the reported value from the previous period can be used in different ways. You can just write the same one from the previous and just put it in this period. But usually it's not like this. Usually you make some kind of adjustment. And this some kind of adjustment is, let's say, one example is that you are looking at the units that you have responses for both periods and calculate what is the average trend. Is it going up or down? And then you multiply the value from the previous period for your imputed value and calculate with this trend, and then you got this estimation. The very similar approach is that you again choose the donor, the one similar unit, and took the trend from the change from this donor, and then multiply the previous value with this trend of the donor. Okay, these are just very quickly the four group of methods that I think that are most frequently used in official statistics. And now it's time for the question for you. What do you think that is in two types of survey the most usually used methods? One is in business survey and one is in social survey. You can vote.
So yes, for business surveys on top and for social surveys on the bottom, try to guess. We'll wait for just a few seconds. So the numbers are still changing. More variability for business, the business world than for the social surveys.
But it is in a way I can show you. Okay.
Yeah.
It is in a way expected, because the truth is that HODEC imputation is, I think, really, without question, the most widely used in social surveys. Why? Because most social surveys have a lot of categorical variables. And I think, in fact, the only method that is really can be used for each type of variables is HODEC imputation. And it's quite expected. What we have in the business service, here we have still answers. Yeah, here we have several, and they're quite much more evenly distributed. Mean imputation, I'm not quite sure about mean imputation. In practice, I didn't meet this mean imputation a lot of times. I think it's simple, but it's this variability problem is quite outstanding. Historical imputation, I would say yes, because in all periodic surveys they are used, and HODEC imputation too. Yeah, the results, I think, quite expected, just a bit surprised that you're favoring of the mean imputation. Okay, I think we can close. I think we are running out of time now, so I will skip two slides, and you can look at them when you will get with them, and you can download them. I will just go to my last slide to conclude my presentation. Unfortunately, we couldn't cover all the topic, but as I said, it's a very wide area and it's impossible to cover this in 1 hour. Just perhaps for the conclusion, a few guidelines for making statistical editing more effective. One, of course, we already talked about it, that data editing should be included in different stages. In data collection, in data analysis, in data processing, and perhaps even more important is that you officially combine this editing in different stages, in different phases. Already said that the validation rules are the cornerstone, the beginning of everything are the validation rules. So it's worth investing in building an optimal set. I mean, at least approximately optimal set of validation rules. Combine effectively manual and automatic editing. Don't be afraid of automatic editing. If it's wisely used, it can be very efficient if you introduce automatic editing in your process. And perhaps also one very important thing, especially if you have automatic editing, it's quite important that you calculate some key indicators, performance indicators we call them, like 3 examples: edit failure rate, hit rate, and data editing impact. Perhaps this one is not so much known. Perhaps I'll just tell you what is data editing impact. It's very simple to calculate this one. Calculate your aggregator, your key statistics before editing and after editing, and then you see what is the difference. And if the difference is very big, it's perhaps a sign that something is not okay with your process. And just to mention that not just to calculate these indicators, the very important is that you analyze it in frequently on the periodic basis. Okay. I think I already said this, analysis of the data editing process and all of these indicators. Okay, I think it's time that I can finish here. Of course, I will answer some questions if they are still here.
Yeah, okay. Well, thank you, Rudi, for this interesting lecture, and many thanks to participants. We haven't collected any more questions now, but we'll be here for some more minutes. Okay, one just came in. How to measure the editing process?
You mean the quality of the editing process?
I guess so. I would, yes.
Yeah. I think only the only way is that you really define your, let's say, this what I mentioned, quality indicators or performance indicators. So the solution is that you really try to assess the process on the immediately when you do the editing, and that you analyze afterwards. So what is the impact to your results? What are the rules that have the highest edit failure rate? What is the hit rate? This is very important. So how many of these validation rules that makes your data suspicious, how many of these data were in fact really corrected afterwards? And this, if hit rate is very low, it's certainly indication that you have something to do with your validation rules, that you have to review them, etc., etc. So there is a quite wide range of this. I just wrote here 3 indicators that can be calculated, that of course doesn't show the quality of your process, but indicates sometimes that something is wrong, that something is imperfect in your process, and indicate you that you should do something with your process.
Okay, how to best report the amount of editing done?
Through quality reports, I think. The quality report, I don't know if all the offices have this practice, but our office have a practice that all these indicators that I mentioned are periodically each year, and much more important, publicly available in the quality report. So make your process, even also editing process, transparent and open to the public, so they know what is going on with your data. What are you doing with your data?
Yes, because this is the process that is completely internal,
Yeah.
and it's important to communicate to the users, especially more advanced users. Okay, what software recommendations for outlier detection would you have?
It's difficult to say because you have a lot of these softwares. I can say from my experience that SAS offers quite a good range of tools for detection. R is now emerging and it has more and more of this and these options for detection of outliers. I think these two packages are at the moment the most actual and the most used also.
In official statistics.
Yeah, in official statistics. Yeah. And there is a constant war among them, but I won't go into this.
Okay. Can you provide some material to go deeper in editing and in the performance indicators?
Yeah, there's a wide list of references. I don't know. Is it possible that we include somewhere that we provide them this list of references?
Yeah, we can add them to the webinar material. Okay. So we can do it later. Rudi doesn't have such a list at the moment, but we could add. We'll probably tomorrow upload the presentation and the link to recordings, and we can then add a few references.
I will provide this. I will not so exhaustive, but quite long list of references from this area.
Okay, so just check the website where you registered for the webinar, and you will get it there. So I think we now exhausted the questions as well. If you wish to download the presentation, please stay with us for, it's already here. So we also invite you this time to complete the evaluation survey. We are very grateful for your comments, for your estimates. And the next webinar is scheduled for next Wednesday, 18th of April, when Maja Pekec from the Croatian Bureau of Statistics and Evelina Konarska-Michalčíková from Statistics Poland will talk about modern approaches to communication of official statistics data. So a completely different topic. And my final comment is that we'll now leave the room open for another 10 minutes or so. And as I said, we'll publish the link to the recording and also the material and the references by the end of the week. Okay. So thank you for now. Have a nice evening. Bye-bye to all parts of the world. Thank you.